Hey everyone, welcome back. We're going to be diving into the decorator pattern today. It's a really interesting way to add features to your code without, ending up with a ton of subclasses.
Yeah, it's one of those patterns that I think once you kind of wrap your head around it, you see it everywhere.
Yeah, for sure. So we're going to be looking at a couple of sources today. We've got an article from refactoring.guru and a YouTube video from Derek Banis. Um, and the refactoring.guru article kind of starts with a problem that I think we've all run into at some point, which is building a notification system.
Right.
So you start off and it's like, okay, we're going to have email notifications, and then, pretty quickly the requirements change and it's like, oh, well, now we need SMS notifications, then we need Facebook notifications, and then
Slack.
Slack. Yeah, and before you know it.
You've got like 20 different types of notifications you got to support.
Right, exactly. And if
Yeah.
you're just relying on inheritance to try to model that, you end up with just this explosion of subclasses.
Yeah, you have the classic combinatorial explosion problem, right? Where you need a subclass for every possible combination of notification types.
Exactly. So you have like email and then SMS and then email and SMS, and then,
It just gets out of hand.
yeah, it
Yeah.
becomes a maintenance nightmare.
Yeah, so the decorator pattern kind of offers a more elegant solution to this. And the way that it works is that you essentially you have this core object, whatever it is that you're trying to add functionality to, and then you wrap it with these layers of what are called decorators, and each decorator kind of adds a specific feature
Right.
without actually modifying the underlying object.
Exactly. And so it's kind of like if you think about like getting dressed in the morning,
Yeah.
you've got, you know,
The article actually uses that analogy.
yeah, you've got like, you put on your shirt and you put on a sweater and then maybe you put on a jacket on top of that, but you're still you underneath all of that.
Right.
It's just you're adding these layers of additional functionality.
Yeah,
Okay.
exactly. And so you can kind of mix and match these decorators depending on what you need at runtime, and you don't have to rewrite the core object every time you want to add a new feature.
Exactly.
Yeah.
It's all about that dynamic adding or removing behaviors at runtime.
Now, Derek Bonas in his YouTube video uses a pizza shot example to kind of illustrate this. And before we get into the pizza, I'm curious, like, why is that dynamic aspect so important? Like, why not just create a bunch of subclasses for each pizza variation? Like, why go through all this trouble?
So the problem is like if you imagine you have a simple pizza class, right?
Mhm.
And you want to offer like pepperoni mushrooms extra cheese,
Yeah.
you start creating subclasses for all those combinations.
Right.
You got pepperoni pizza, partial pepperoni straight pizza, and it just gets crazy.
Right.
And so like what happens if you have to change the price of pepperoni?
Right.
Now you got to go through all these subclasses and update the price in each one.
Oh, yeah, that's
It's tedious and error prone.
Yeah, so what the decorator pattern allows you to do is instead of having these static subclasses, you have these decorator classes for each topping. So like
Right.
you'd have like a pepperoni decorator, mushroom decorator, extra cheese decorator, and then you can kind of compose those together to create any pizza you want.
Right. And so if you need to change the price of pepperoni, you just change it in the pepperoni decorator class.
That makes a lot of sense.
And it automatically applies to any pizza that has pepperoni on it.
So it's not just about like avoiding a ton of subclasses, but
Yeah.
it also makes your code way more flexible and easier to maintain.
Right, exactly.
Okay, so Derek in his video, he kind of starts by showing the wrong way to do it, like with all these subclasses, and then he introduces the decorator pattern and shows how you can actually use it to build a pizza.
Yeah.
And he walks through some code examples and everything.
Yeah.
Before we get into like the specifics of Derek's pizza example, I think it's worth kind of taking a step back and looking at how the decorator pattern kind of relates to this broader idea of software design principles. You were talking about flexibility. How does that kind of tie into the bigger picture of how we design software?
So one of the key principles in software design is the open-closed principle.
Okay.
And the idea is that software entities should be open for extension, but closed for modification.
Okay. What does that mean?
So that means that you should be able to add new functionality without changing the existing code.
Okay. So I can add new features without having to go back and break the things that are already working.
Exactly.
Okay.
And the decorator pattern allows you to do that because you can add new functionality by creating new decorators.
Right.
And you don't have to touch the original code.
So you're extending the behavior,
Right.
but you're not modifying the core structure. Okay, that's really interesting. So it's not just about like pizza toppings, it's about building software that's adaptable,
No.
can change over time without breaking.
Exactly.
Yeah. Okay, well let's get back to that pizza shop and see how Derek kind of breaks this concept down with his delicious example.
All right, let's go.
Okay. Okay, so we're in Derek's virtual pizza shop, ready to see this decorator pattern in action. And he starts by kind of showing us the wrong way to do it first, with the inheritance. So can you remind me, what's the issue with just creating like a subclass for every pizza combination?
Yeah, so you start with your base pizza class, and then you want to add toppings like pepperoni mushrooms, extra
Right.
cheese, and you create subclasses for all those combinations. You
Right?
get pepperoni pizza, mushroom pizza, extra cheese pizza,
Yeah.
pepperoni mushroom pizza, and on and on and on. It just explodes.
Right. Yeah, the combinatorial explosion.
Exactly.
And as we talked about, if you need to change the price of pepperoni, suddenly you've got to go and update like, dozens of subclasses. So Derek's showing us this kind of chaos to set the stage for how much better the decorator pattern is, right?
Exactly.
Okay, so with the decorator pattern, instead of having all those subclasses, we have these decorator classes for each topping. So we might have like a pepperoni decorator, a mushroom decorator, an extra cheese decorator, um, and then we can kind of compose those together to build up whatever pizza we want.
Right.
Okay, so I'm following. So far, we've gotten rid of this massive subclass hierarchy, and we've replaced it with these individual decorators. But how do we actually use those to build a pizza?
So each decorator class basically wraps another pizza object. So you start with like a plain pizza object.
Okay, our base pizza.
And then you wrap that with a pepperoni decorator to add pepperoni.
So now I have a pepperoni pizza.
Exactly. And then you wrap that with a mushroom decorator.
So it's like we're layering these decorators on top of each other.
Exactly.
Really?
And each decorator adds its own functionality, like adding the topping and updating the cost and the description and all that.
Okay. Now, the refactoring.guru article, they have this kind of structural diagram for the decorator pattern.
Yeah.
I gotta say, sometimes these diagrams, they make my eyes glaze over a little bit. Can you kind of break it down for us? Like, what are the essential elements of that diagram?
Sure. So I think the diagram can look a little intimidating, but it's a pretty simple concept. So you have like the component interface,
Okay.
and that basically defines the common methods that both the concrete pizza object and the decorators are going to need to implement.
Okay, so in our pizza example, this might be like a method called get description or get cost.
Right.
So we can get a description of the pizza, we can calculate the cost.
And it doesn't matter how many decorators have been applied, it'll still work.
Okay.
And then you have the concrete component, which would be like our plain pizza class.
Okay, so that's just our basic pizza with dough, and it implements those methods.
Exactly. And then you have the decorators, and there's like a base decorator class. This is where it gets a little abstract. But basically, the base decorator class acts as a bridge between the concrete pizza and the specific topping decorators.
Okay.
And it has a reference to a component object, which can be either a plain pizza or another decorator.
So the base decorator can wrap a plain pizza, or it can wrap another decorator.
Yeah, that's how you can chain them together.
Okay.
And importantly, the base decorator also implements the component interface.
Okay, so it's like from the outside, whether I'm dealing with a plain pizza or a pizza that's got like a dozen toppings on it, it all looks the same because they all adhere to that component interface.
Exactly right. That's one of the nice things about the decorator pattern is that it gives you this consistent interface regardless of how complex the decoration is.
Okay, I'm starting to get this now. So we've got we've got the concrete component, we've got the base decorator. What about the specific toppings like the pepperoni, the mushrooms?
Right, so those would be the concrete decorator classes in the diagram.
Okay.
So each concrete decorator class extends the base decorator and it adds its own specific functionality.
So like pepperoni decorator would extend base decorator, and it would have the logic for like adding pepperoni to the pizza and updating the cost.
Right, and it overrides the get description and the get cost methods from the component interface.
Okay.
And it basically adds its own behavior on top of the existing behavior.
So if I had like a pizza with pepperoni and mushrooms, the mushroom decorator would call the pepperoni decorator, which would then call the plain pizza to kind of get that base cost and description.
Exactly. It's kind of like a chain of responsibility.
Okay.
Where each decorator adds its part, and then eventually it all bubbles back up to the concrete component.
Okay. This is all starting to make sense now. Is there ever a reason like not to use the decorator pattern? Like, are there downsides? Are there things we should be aware of?
Yeah, I mean, like any design pattern is not a silver bullet.
Yeah.
There are some potential drawbacks to be aware of.
Okay, what are those?
So one thing is that if you have a really deeply nested stack of decorators, it can get a little tricky to remove a specific decorator from the middle of the chain.
Yeah. Trying to unwind all those layers could be a pain.
Yeah, and another thing is that you want to make sure that the behavior of your decorators doesn't depend on the order that they're applied.
Okay.
If the order matters, then things can get really messy.
So ideally, they all kind of play nicely together no matter how you arrange them.
Exactly.
Okay.
And then the last thing is that the initial setup code for creating all these decorator classes can feel a little bit verbose sometimes, especially if you have a really complex hierarchy of features.
Okay, so there's a little bit of upfront investment, but I guess, the flexibility and maintainability you get in the long run probably outweighs that.
Right, most of the time, yeah.
Okay, well, all this talk about pizza is making me hungry, but before we take a break for lunch, let's think about this. How does the decorator pattern apply to real-world software development? Where might our listeners actually encounter this in their work?
Yeah, I mean, it's actually a pretty versatile pattern. So, like, think
Cool.
about any time where you need to add functionality to an object without changing its core structure.
So, like, if I'm building a software application, I might have different features that I want to be able to turn on or off. I could have like a decorator for user authentication or a decorator for logging
Which
or
are
a decorator for data validation or something like that.
Right, or like customizing a car. You
Mm.
got the base model of the car, and then you can add leather seats or a sunroof or navigation system.
Mm.
All those are basically decorators.
Or even in like graphic design, you have layers in Photoshop and you can add different effects to the image without actually changing the original image. So it's all about kind of, adding these layers of functionality without messing with the core object.
Exactly.
Yeah, it's amazing how this one concept, this decorator pattern can show up in so many different areas.
Right. Like, I think it speaks to the power of patterns in general.
Yeah.
Like, they give us these blueprints for solving common problems, whether it's,
Hmm.
lines of code or layers of cheese.
When I first started learning about design patterns, I was so intimidated by them. It was like this whole other level of abstraction.
Right.
But as we've talked about today, once you kind of understand the concept
Mhm.
and see how it applies to real world examples, it's like, oh, okay, I get it.
Yeah, and that's what makes it fun.
Yeah.
Those aha moments where something clicks and it's like, oh, now I understand.
Speaking of aha moments, have you had any like memorable experiences in your own work where the decorator pattern has kind of like saved the day or like really come in handy?
Yeah, I mean, I can think of a time when I was working on this data processing pipeline,
Okay.
and we had all these different stages in the pipeline, and each stage could have different transformations applied to the data.
Okay.
And at first we were using all these like conditional statements and nested loops to handle all these transformations,
Oh, man.
and it was a nightmare to maintain.
I bet.
And then I realized, we can use the decorator pattern for this. So we had like a base data processor component, and then each transformation was a decorator class.
Okay.
And it just wrapped the previous stage in the pipeline.
So you could just like add or remove transformations by adding or removing these decorator objects.
Exactly. And the core data processing logic didn't have to change at all.
Wow.
We just decorated it with the transformations that we needed.
And was that like a big improvement in terms of the readability and the maintainability of the code?
Oh, yeah. Huge. It made the code so much cleaner and more modular.
So it sounds like the decorator pattern really saved you a lot of headaches in that project.
Definitely.
Well, as we wrap up our deep dive into the decorator pattern, I want to leave our listeners with a thought to kind of ponder. We've looked at all these different examples, but I think the real power of this pattern is that it can kind of inspire you to think about problems in a different way. So, look around, you look at the systems and processes you encounter in your daily life. Where do you see opportunities to kind of like add functionality or enhance features or customize behavior without, disrupting the core structure of things?
Yeah. Think about how you can apply this concept of decoration.
Yeah.
Could you use it to streamline a workflow or personalize the user experience, or even, create a more adaptable learning plan?
I love that.
The possibilities are endless.
Keep those decorator goggles on.
Exactly.
Well, it has been a fascinating journey exploring the decorator pattern with you today.
Your pleasure.
And a huge thanks to our sources, refactoring.guru and Derek Bonas,
Yes, thank you.
for providing such clear and engaging explanations. Until next time, keep diving deep.